awesome people. In the last video, we discussed how you can deploy a Mosquito broker on AWS. And we also discussed how you can implement username and password authentication, as well as have a custom domain for that broker. Continuing from that, I wanted to discuss how you can migrate a setup like that onto AWS IoT while using the same authentication method, which is username and password, as well as using the same custom domain, right? So let's get started. So just to go over what we will be doing today, the first thing we'll do is understand the flow of custom authentication. Next, we'll go ahead and create a custom authorizer. And lastly, we'll dive deep and do a lot of testing. So let's go over the authorization workflow. Specific to our use case, whenever a device connects to AWS IoT, makes the connect call and presents with the credentials, AWS IoT checks for two things. One, if the incoming request specifies an authorizer, and also if the AWS IoT core default data endpoint has a default authorizer configured for it or not. If both of these conditions are satisfied, a Lambda function will be invoked. So this is the Lambda function that does the authorization function in this use case. Now, when this Lambda function is invoked, AWS IoT will send the credentials and connection data as the payload to the Lambda function. So in our case, when the client connects to AWS IoT using username and password, AWS IoT core will send that information as a payload to the Lambda function. And that Lambda function has to make an authentication decision. This authentication decision includes verifying the credentials as well as returning an IoT core policy document. One thing to note is that this policy document is cached with AWS IoT, and we can define for how much time it will be cached. We can also define in the payload returned by the Lambda function that after how much time should the connection be disconnected automatically. Lastly, when this policy reaches AWS IoT core, the client can then perform all the actions that are allowed in that policy document, such as connect, subscribe, publish, and receive. One small thing to note when using custom authentication at scale is that the Lambda function is subject to Lambda function pricing as well as Lambda function limits, such as concurrent execution, right? So if you want to manage the frequency at which the Lambda function is invoked, you can do this by adjusting the refresh after in seconds parameter as well as disconnect after in seconds parameter. According to the documentation, we need essentially two things in our current setup. The first is a name for the custom authorizer and a Lambda function ARN that will be invoked to get the credentials checked and return a policy. So let's go to the Lambda function console and create a function. I'll call this custom auth for username and password, and I'll select the language as Python 3.9. I'll leave everything else as default. Great, so the Lambda function is now created. I'll add a small line to print the incoming event. I'll also copy the function ARN to use when we are creating the custom authorizer. That being done, let's go over to AWS IoT and create our custom authorizer. So you can find the custom authorizer link over here in secure authorizers, and we'll go ahead and click on create authorizer. I'll give this a name. So I'll give this the same name as my Lambda function, and I'll also select the Lambda function as this one. Perfect. I'll leave everything as empty because we are not using token validation as of now. Now I'll click on activate authorizer and create the authorizer.
A few moments later.
After having created the authorizer, we will test invoke it from CLI and then observe what kind of event do we get in the Lambda function, right? And then using that event, we will write our code which will authenticate the incoming user, right? So to make that CLI command, we will use this one. This is called test invoke authorizer, and as a parameter, we have to give the authorizer name as well as the MQTT context. So this will contain the username and password. Cool. So what I've done is in my GitHub repository, I've added all the files that will be required in this video. And also in there, I have CLI commands for test invoking the authorizer. So let's copy that and invoke it via terminal. Cool, so we got an error. This is expected because the Lambda function is currently not returning the expected response. Cool. So let's go to the Lambda function to observe the incoming event. We'll go to monitor, view logs in CloudWatch. Go to the log stream and then click on view as text. So here you can see there is a protocol data for MQTT. We got the username and we got the password, right? So this is the format of the incoming request. Let's move over to the documentation and just dive brief further into this incoming event. Here, let's scroll down. Here's a section where we understand what is the incoming payload and also what kind of response should be sent by the Lambda function. So looking at the payload, we've got all the expected fields that we got in our logs. So we'll have the protocol data. If it's TLS, if it's HTTP, if it's MQTT. So TLS will contain server name, HTTP will have all the headers and the query strings, and MQTT will have the username and password, which is what we are going to be using. Protocols defines what protocols were used to make that connect call. In our case, we only made the MQTT payload, right? So that's why we only got MQTT protocol over here. However, when we used our code and we use the ALPN protocol to connect to AWS IoT, in that case, we'll see that both TLS and MQTT will be populated and we'll get payloads for both of these, right? Lastly, we'll see the username, password, and client ID. This is the exact same structure as we got in the logs, right? Now let's talk about what kind of response has to be sent by the Lambda function back to AWS IoT. Currently, we have the wrong response. That's why we're getting an error. Cool. So first thing is authenticated. This is a Boolean value, true or false, whether the Lambda function says that the incoming client is authenticated or not. Principal ID is like an identifier for the token. You'll see that in the logs as well. When the client makes a publish call, you'll see the principal ID over there. Next is the policy document. This is the JSON file containing all the permissions that are granted to the client. Disconnect after 10 seconds. We discussed this before. This specifies the maximum duration for the connection of the client, right? And refresh after in seconds is interval after which the policy will be refreshed automatically. Scrolling down, we have a sample response payload. So here you can see Boolean value. This is some random. These two values, you can set them as default or something different. And then this is the policy document. So essentially we have to write a piece of code which will first evaluate the incoming username and password and then send back this kind of a response. So having understood that, we'll go back to our Lambda function and write the pieces of code for one, to check the incoming username and password, and second, to send the right response back to AWS IoT Core. Now to make things simple, I have uploaded that exact piece of code into my GitHub library, and I'll just copy the same thing and paste it on the Lambda function. I'll go over the code as well. So I'll just copy all and paste. So I'll scroll up. Let's just go through over the code. The first thing we'll do is print the incoming event. Next, we will pick out the password, base64 decode it, and then check if it matches with this string value, which is secret password. So this is what I'm expecting as the correct password. If it's correct, we'll move forward. If it's not correct, we will calculate a result saying is authenticated as false, and then just close the Lambda function. So it will end and send back the result. However, if it's successful, if the password matches, we will create a policy like this one. So it allows connection, it allows publish, receive, as well as subscribe, and calculate the result using that. So authenticated is true. Principal ID, I've added something random. Policy document, just as the above one that I showed you. And then these two values are just default, and then we'll send them back, right? I'm also printing the results for logging purposes. Let's save our Lambda function as well. and we'll go back and make the same CLI command again. See, so this time it was authenticated and we got the perfect policy back as well. One thing I'll do is I'll try to use an incorrect password. So back in my CLI commands, I have two commands, right? So one was correct password, the other one is incorrect. So let's try that as well. Copy that, paste. See, it says is authenticated as false, which means the password was incorrect. Let's also look at our Lambda function logs to make sure we got all the right values. So I'll click on the latest log stream, click on view as text. So here we got the payload. Encoded password was this, decoded password was secret password, and we printed the policy and we printed the result that was sent back to AWS IoT. Next, the second invocation, we got the same payload with a different password, and then this time it says boring password, right? And then it says password authentication failed. Cool. So we've done that. We have done our authorizer Lambda function, and next step is to test the same thing out from our IoT device. So in my previous video, I wrote a code which was communicating with Mosquito Broker, and now what we'll do is we'll modify that same code and have it communicate with AWS IoT. So let's do that. Moving over to the GitHub library, I'll go back to this folder, and here I have both of those codes. So first one is Mosquito Bajo. This one is communicating with the Mosquito Broker, and this one is the same piece of code almost modified to communicate with AWS IoT. So let's quickly go back to our terminal, and we'll invoke both of these, and then we'll go through what actually happened by looking at that code. So first I will run the piece of code that will publish to my Mosquito Broker. As you can see, it's publishing perfectly, right? If you want to learn more on how I built the entire architecture and wrote the code, I would highly suggest you to refer to my previous video. Cool. Now before publishing to the cloud, I'll quickly go over and subscribe to the MQTT topic. Cool. Let's go to IoT Core, test, and then subscribe. So this is the topic on which the code will be publishing. Cool. Now you can see that the messages have start to arrive. We'll go back to the CloudWatch logs, refresh, and we can see there was an invocation on the Lambda authorizer. I'll go over here and expand. Here you can see the protocols are now TLS as well as MQTT, whereas previously when we were test invoking, we only got MQTT. Like I mentioned, since we are using the ALPN protocol and communicating over 443, we get both TLS as well as MQTT. The username is now different, so I'll actually go through the exact code and what needed to change when migrating from publishing to the Mosquito Broker than publishing to the AWS IoT, right? So first, one thing is changing the username to include the custom authorizer name. The parameters are pretty much the same as before. Username, password. The username was the same. The password was authenticated, and then the policy was returned. Cool. Now let's go over and actually look at those two pieces of code side by side and compare.